Now, grade 8 students, we are going to continue our lesson, and that is for lesson 1 work. How to calculate work? Work is done when the force F applied to the object caused the object to have a displacement d in the same direction as the force applied. The symbol for work is a capital W. The work done by a force can be calculated as, this is our formula, W is equal to F times D, where W serves as our work and F as our force and D as the distance covered or the displacement. As you have learned, the unit of force is, remember, it's kilogram times meter per second squared or Newton. This is our unit of force. Hence, we can say that the unit of work is the unit of force multiplied the unit of displacement. So our unit of work is N, which is in Newton, multiplied by meters. Okay, so the unit of work is Nm or joules. The unit joules or J is named after an English physicist named James Prescott. Okay, let's watch what's the physical appearance of James Prescott Joule. So here is the image of James Prescott Joule. Okay, so here he is. Hello there. Okay, so this is also the unit of energy. Joule is also a unit of energy. 1 joule is equal to work done or energy expended in applying a force of 1 Newton through a distance of 1 meter. So again, 1 joule is equivalent to a force of 1 Newton through a distance of 1 meter. Alright, we are going to calculate some problem solvings here in our chat with the expert. Suppose a woman is pushing a grocery cart with 500 Newton force along the 7 meters aisle. How much work is done in pushing the cart from one end of the aisle to the other? So we are going to copy this one. Let's try, and then let's paste it with our whiteboard. Not whiteboard now. It's our yellow board. Okay. So we are going to solve. Here. Here is our given. Yan. Okay. So here, let's try to enumerate the given. Okay, so given are the following. Suppose a woman with 500 Newton, so that serves as our force, 500 Newton. And then 7 meters, that serves as our distance, 7 meters. How much work is done in pushing the cart from one end of the aisle to the other? So we are going to put our formula here, and then we are going to use our formula given. W is equal to F times D, where F is 500 Newton, and multiply it with the 7 meters. So if you have your human calculators, of course, we can multiply it this by this. 7 times 0 is 0. 7 times 0 is 0. 7 times 5 is 35. Therefore, our work done is 3,500 Newton meter or joule. 300,500 joule. Okay, so here is our result of our sample problem. Okay, this is our work. Okay, so we already know how, therefore we can proceed to our next work done in different situation. In science, getting a stone from the ground is already considered doing work. The force exerted in lifting the stone and the height at which it's lifted are the factors involved in the work. So, as you can see, we have here the force done and then the distance going up, or the height from the ground maybe to the raising up, or the lifting up of that object. So analyze the following example of work in different situations. So example number 1. A port worker lift a sack, okay, of rice onto his shoulder with a force of 300 here. Okay. At a height of 1.5 meters. So this is the height, that is in distance. How much work did he do? With a sack of rice on his shoulder, the worker walked at a distance of 10 meters. How much work did he do as he carried the sack of rice while walking? So, first, we are going to find the work done in lifting, and we are going to find the work done in walking. So, let us have the whole scenario of our example so that we can copy it and then paste it in our yellow board. So this is our example. Okay, copy and then paste. Okay, here is our example. Okay, so okay, where is it? Copy and paste. All right, so as you can see, we are going to enumerate first the given. Okay, given. Okay, let's try to concentrate on the lifting. Okay, so we have here the force is equivalent to 300 Newton, and then the height, or the distance in height, is equivalent to 1.5 meters. And how much work did he do? So we can now calculate it by the formula. Okay, W in lifting is equivalent to force 300 Newton times 1.5 meters. Okay, so if you are going to use our calculator, you will have okay, so we will have 300 times 1.5, so it's 450. Okay, 450 Newton times meter, or 450 joule. Yan. This is the work done during the lifting of the sack of rice. Okay, let's proceed to the second part. Okay, how about, okay, this is the first part. Let's go to the second part. Work done while walking. Okay, so same, we are going to use the force 300 Newton while our distance is here. As you can see, it's 10 meters. So 10 meters. We are going to use the formula. Okay, work while walking, we have 300 Newton times 10 meters. So the result will be 3,000 Newton meters, or 3,000 joules, that is work while walking. Okay, let's go back to our given. So the worker walked a distance of how much work did he do as he carried the sack of rice while walking? Okay, so here is our answers.